Dear students, welcome to first PU physics class. In this class, let us deal with the chapter Mechanical Properties of Solids. When external force applied on a body, then length, volume or shape and size changes, then the body is said to be deformed, and the applied force is called deforming force. Okay, when body is deformed, a restoring force is developed internally which opposes the deforming force. Okay, here the restoring force means it is the internally developed force. Okay, and deforming force is it is externally applied force. So at equilibrium, the restoring force is equal and opposite to external deforming force. Okay, hence we can conclude that in order to deform the body or to change shape or size of the body, the external force is required. Okay, consider an example. Here, if we stretch a helical spring by gently pulling its ends, the length of the spring increases. Okay. On leaving the ends of the spring, it regains its original shape and size. Okay, right. So this property is called as elasticity. Okay, hence the elasticity can be defined as it is the property of material of the body by virtue of which the body regains its original shape and size on removal of deforming force. Okay, here the deforming force means it is externally applied force. Next, the elastic bodies. The bodies which possess property of elasticity are called elastic bodies. Okay, here the examples for elastic bodies are rubber, steel, etc. Okay, here the quartz is nearest perfectly elastic material. Okay, so next is plasticity. The property of material of the body by virtue of which the body does not regains its original shape and size on removal of deforming force. Okay, and those bodies which possess property of plasticity are called as plastic bodies. Consider an example. So if we apply force to a lump of mud, so it get permanently deformed. Okay, so it has no tendency to regain its original shape. Okay, such property is called as plasticity. Here the wet clay, paraffin wax, etc. are example for plastic bodies. Okay, and a perfectly plastic material, so you can give example as mud. Okay, right. So next topic is stress. It is internal restoring force developed per unit area of a deformed body. Okay, here what happens when a body is subjected to deforming force or an externally force is applied to a body, then a restoring force is developed in the body, and In equilibrium state, this restoring force is equal and opposite to the applied force. Okay, here, so equal and opposite means both the forces are having same magnitude. Okay, restoring force and the applied force or deforming force, both are having same magnitude but acting in opposite direction. Okay, so say for example, here you are considering a body. Okay, so in this direction the external force is applied. Okay, or deforming force is applied. Okay, then the restoring force is developed in this direction, internally in the body. It is restoring force. Okay, right. So stress can be written as it is restoring force divided by area, which is equal to deforming force by area. Okay, here capital F is deforming force applied to an area of cross section A of the body. Okay, here capital A is the area of cross section of the body. Then stress can be written as stress equal to F by A, force by area. Okay, and here the SI unit of stress is Newton per meter square. As you know, the SI unit of force is Newton and the SI unit of area is meter square. Hence, the SI unit of stress is Newton per meter square. Okay, and also you may write dimensional formula. Types of stress. There are three types of stress. First one, longitudinal or normal stress. So again, so in that there are two subtypes, tensile stress and compressive stress. Next, tangential stress, and last one is hydraulic stress. So let us discuss one by one. Longitudinal stress. It is also known as normal stress. So normal means here the force is applied perpendicular to the surface of the body. Okay, or the force is applied normally to the surface of the body. If deforming force acts normally over an area of a body, the restoring force per unit area of deformed body is known as normal stress or longitudinal stress. Okay. So you may consider this example. So in both the examples, here the force is applied perpendicular to surface of the body. Okay. So now consider its types. Tensile stress. When length of a body increases in the direction of deforming force, then the restoring force per unit area of the body is called tensile stress. Okay, means when the force is applied to the body, the elongation takes place. Okay, so in such case, the restoring force per unit area is called as tensile stress. Okay, elongation means it's increase in length. So consider this diagram. Okay, here the original length of the body is L. Okay, when the deforming force is applied, then length increases to L plus delta L. Okay, here the delta L is small increase in length. Okay, right. So such type of stress is called as tensile stress. Okay. Next, compressive stress. Here, when the length of a body decreases in the direction of deforming force, restoring force per unit area of the body is called compressive stress. Okay, here compressive means on the application of external force, length of the body decreases. Okay, right. Again consider the diagram. Here the original length of the body is capital L. Okay, here the deforming force is applied. Then a length of the body is decreases to L minus delta L in the direction of the applied force. Okay, so in such case the restoring force per unit area is called compressive stress. Okay, in tensile stress the length is increases to, so length is increases to L plus delta L. Okay, and in compressive stress L is decreases to L minus delta L. Okay, where delta L is small change in length. Here the positive sign indicates length increases and here the negative sign indicates length decreases. Okay. The second type of stress is tangential stress. When deforming force acting tangentially to a surface, the restoring force per unit area of the body is called tangential stress. Okay. Here consider the diagram. In this diagram, the surface AB is fixed. Okay, you consider a rectangle ABCD. So in which the surface AB is fixed and force is applied parallel to the surface CD. Okay, here the force is applied parallel to the surface CD, so that the body is sheared by an angle theta. Yes, here the original position is ABCD, right? Here on the application of external force, so this rectangle is sheared and the position is displaced. The displaced position is represented by AB, C dash and D dash. Okay, AB, C dash, D dash. Okay, here the body is sheared by certain angle theta. Okay, sheared or shifted by an angle theta. Then here the restoring force per unit area of the body is called tangential stress. Okay. And here this angle theta is called as shearing strain. So we learn the types of strain in next slides. Okay, right. The third type of stress is hydraulic stress. When a body is compressed uniformly from all sides by application of deforming force, then restoring force per unit area of the body is called hydraulic stress. Okay. So in this stress, the volume strain is produced. Okay. So if you consider an example, so a rubber ball is pressed from all sides, okay, then its volume decreases. When pressure is removed, the ball regains its the original volume, okay. Hence, on the application of this hydraulic stress, the volume strain is produced, okay. Okay. So now let us discuss about strain. When body is deformed, the ratio of change in configuration to the original configuration is called strain. Okay. Here configuration means the dimensions of the body. So it may length or area or volume. Okay. Right. Here the strain is dimensionless quantity and it has no units. Because here if you consider the formula for strain equal to so simply I will consider so length as a dimension, okay. It is the ratio of change in length to original length. Change in length is represented by delta L divided by the original length is L, okay. Here the dimensions of both these quantities are same, hence so both the dimensions are getting cancelled. Hence strain is dimensionless quantity and also it has no units because it is the ratio of two numbers, okay, ratio of two numbers. So there are three types in strain: longitudinal strain, volume strain, and lastly shearing strain, okay. So first one is longitudinal strain. So it is also known as tensile strain or compressive strain, etc. Okay, right. So generally it is treated as tensile strain. Okay, so it is ratio of change in length to the original length. Okay, so the longitudinal strain can be written as delta L by L, where delta L is change in length and L is the original length of the body. Okay, right. Here the longitudinal strain or tensile strain is produced when the longitudinal stress is developed in the body. Okay, you studied in last slides. So this one, longitudinal stress. Okay, so this is a tensile stress. Okay, when the deforming force acts normally on a surface of a body, then the longitudinal stress is produced and also the produced strain is longitudinal strain or tensile strain. Okay, so next second one is volume or bulk strain. So it is ratio of change in volume to the original volume. Okay, so such a strain is produced when the hydraulic stress is developed in the body. Okay, right. Here the volume strain can be written as delta V by V, where delta V is change in volume and V is the original volume of the body. Okay. Next, the third type is shearing strain. It is ratio of relative displacement of one plane to its distance from the fixed plane. Okay, so as I discussed earlier slides, that is in shearing stress, right? Here tangential stress or shearing stress in this example. Okay, here when the deforming force is applied tangentially to the surface, then the produced stress is called as tangential stress. So and this angle theta is called as shearing strain. Okay. Okay. So hence the shearing strain is equal to angle through which a line originally perpendicular to fixed plane. Okay. And here the shearing strain can be expressed as angle theta. Shearing strain equal to angle theta. Okay. Right. Next, Hooke's law. It is important for your exam point of view. Okay. The statement as follows: within elastic limit, stress and strain are proportional to each other. Okay. Here, what do you mean by elastic limit? So it is the upper limit of deforming force for which body can regain its original form. Okay. Or it is the maximum stress. So it is the maximum stress up to which an elastic body will recover its original shape and size after the removal of the deforming force. Okay. So that is known as elastic limit. Okay. So according to Hooke's law, we may write stress is directly proportional to strain. Okay. That is stress equal to K into strain, where K is constant of proportionality. It is known as modulus of elasticity. Okay, modulus of elasticity. Here the modulus of elasticity is ratio of stress by strain. Okay, modulus of elasticity is equal to stress by strain. Okay, so remember this expression for modulus of elasticity. Okay, right. Next is stress strain curve. It is also important. So question may be asked for 3 marks. Okay, right. So this represents the stress strain curve. Here the stress is taken along y-axis and strain is taken along x-axis. So in this curve, 4 positions are marked such as A, B, C, D. Okay, so let us discuss those positions with respect to the graph. Okay. So in this graph, the O represents the origin. Okay. The region between O to A. Okay, the region between O to A, the curve is linear or the curve is straight line, which represents the stress is proportional to strain. Okay, means the Hooke's law is obeyed and the material behaves as an elastic body. Okay, because in elastic body only the stress is proportional to strain. Okay, and all the elastic bodies will obey the Hooke's law. Okay, so hence the region between O to A or OA represents the elastic behavior of the body. Right. Now consider the next region AB from A to B. Okay, from A to B the curve is not linear. Means curve is not here. The plot is not straight line. It is curve. Yes. Okay. Means in this region the stress is not proportional to strain. Okay. right? So here the point B is called as yield point, and the stress corresponds to this yield point is called as yield strength, So now consider the next region, BC. Okay, so in this region the strain increases rapidly. Yes, the strain increases rapidly even for the small change in stress, because the curve is flat here. Okay, so here the strain increases rapidly, so even for the small increase in stress. Okay, or so we may say that here the stress is increased beyond the elastic limit. Okay, so in this region the body does not regain its original shape and size. Okay, so in this region the material is said to be a permanent set. Okay, permanent set or permanent extension means, so on the removal of force the body does not regain its original length or original shape or size, hence it is said to be the permanent set. Okay, right. And here the strength corresponds to, or the stress corresponds to point D. Stress corresponds to point D is called the ultimate strength. Okay, ultimate strength means beyond this point the strain increases even the applied force is removed. Okay, right, beyond this point here the strain increases even the applied force is removed. Okay, and finally the fractures occur at position E. Okay, fracture means here the body may break. Okay, right, here E is called as fracture point. Okay, right. Here, so according to this graph, generally the materials can be divided into two types, brittle and ductile. Okay, so if suppose the points D and E are close to each other, then fracture occurs early or as soon. Okay, such materials are called as brittle. Suppose these points are far apart, point D and point E are far apart, then the material is said to be ductile. Okay, materials are said to be ductile. For ductile materials we can give example like copper, silver, gold, iron, etc. Okay, right. So in next class, so we will study about the types of modulus of elasticity and Poisson's ratio, next elastic energy, etc. Thank you.